I'm starting a new series, and the series is focused on the robotics side of things, in particular, foundation models for robotics. So when we work here, in particular, as related to our portfolio, we are obviously interested in self-driving, and it's been our interest for the last couple of years. And I think what's happening in really in real time almost is that we're witnessing the transition from dedicated bespoke models into foundation models. And foundation models are models that are, as the name says, the foundation for other applications. So what that means in practice is that we are going to have a foundation model that can be used for self-driving, and we are going to have the same model with some fine-tuning and tweaks and maybe some architectural changes on top of the stack for, let's say, robotics. I mean, this is obviously exactly what Tesla's doing with the humanoid robot. This, in our opinion, is the reason why Elon Musk is yelling and screaming now that he wants more control, because this is what's going on. This is what we're seeing right now in the scientific community, and of course also in the technological and entrepreneurial space. But before I go into details, and by the way, this is going to be a long-term conversation. I can't encompass this in a 20-minute podcast series or anything like that. So what I'm going to have to do is, just continue working on these themes. I'm going to start today with a really good paper. It's a summary of autonomous driving technology. It's a nice summary. It's also a structured view of the situation, which I think is very important, because when these types of new paradigms happen, again in this case, the shift from bespoke machine learning methodologies, task-specific machine learning technologies, towards a foundation model that then can be translated into different modalities, such as humanoid robot, self-driving car, drones, you name it. When these types of transition shifts happen, I think it's incredibly important to understand the structure of the problem set. So, for example, we're going to have, perception, planning. We're going to have, the question whether it's model-based reinforcement learning, or whether it's off-model or online reinforcement learning. Like, all of these questions need to be structured, fundamentally structured, so we can then, as researchers and portfolio managers, start digging into the specific segments of the structure and learn more about it. So what that means in particular is, for example, when we're talking about building a world model, right? When we're talking about building a world model, we have to understand what is a world model. A world model is the representation, let's say in the space of autonomous driving, it's the representation of the traffic scenario. And then you have to predict let's say the next 5 or 10 or 20 or 30 future steps in that traffic scenario. And the question within that particular problem is, okay, how are you going to do this? Let's say, what kind of statistical methods are you going to do? What kind of probabilistic modeling are you going to do to actually do that? How are you going to deal with, non-stationarity, which means that, is it even possible in principle to predict the next 10 steps in a traffic scenario? It's just going to blow out. You're going to have, a car crossing the street, and then 5 steps from now, this car will basically be, crashing into a wall or something. How do you control for these things statistically? So these are there's papers written about that. Then you have the problem, let's say, of depth recognition within the recognition of a scene, which currently is being tackled with occupancy networks and nerves. There's other interesting ideas. That's another research area. Then we have the whole planning scenario. For example, are we using planning scenarios? Are we using actor-critic models for planning scenarios? If we do, then okay, how do we do that? This is reinforcement learning 101. What kind of network, what kind of ideas are we using to solve for some of the typical problems in reinforcement learning that an actor critic model brings with it. Should we even use an actor critic model? Well, obviously, it's in end-to-end learning, it's going to be difficult not to use something along those lines. But then we have a world model also. So we're using model-based reinforcement learning, or are we using, again, actor critic, which is sort of a combination. So those are the sort of questions that this paper helps to tackle. It's not solving, it's a summary paper, so it's not really giving any insight into, okay, this is how we should do it, and these are the problems. It's not doing any ablation study or any of those things. It's just a summary. I'm going to discuss it in more detail. This particular episode is just an introduction, and then hopefully today I can also push out the first episode in this new series. So I'm not going to call it anything else. Like, it's still part of the Not Even Wrong podcast. I'm just going to announce it in the taglines, of course, and also in the prelude. So I'm going to call it Foundation Models for Decision-Making Agents, Foundation Models for Decision-Making Agents. This is the working name. Yeah, I might change it. So I'm keeping it general because, again, this is not about self-driving anymore. This is about decision-making agents. And maybe I should add the embodied word, embodied decision-making agents. So this is what this is all about. In other words, I'm not going to really spend a lot of time thinking about how to predict advertising clicks or things like that. It's going to be about embodied decision-making agents. And the key, again, the reason I'm starting this series is because the foundation models are a new paradigm. We're going from task-specific towards foundation, and this is why this is an interesting avenue to pursue. And I think there's so much research coming out in real time that it's worth having a more structured conversation about this. So this is the prelude to the series about foundation models for embodied decision-making agents. It's going to talk about perception and vision, representation of a world model, planning, reinforcement learning, off versus online, model-based versus not model-based. The first paper I'm going to discuss is a paper that came out recently. It's Forging Vision Models for Autonomous Driving. It's a summary, and I think it's a good starting point to dissect the problem and discuss it in more depth. The key problem of end-to-end autonomous driving is really how to represent the world, how to represent the model, and then how to predict the future of that representation, and then plan to navigate that future, and then link that planning to low-level actions. In other words, gas, brake, steering wheel, things like that. So this is really the foundation. I think this paper, Forging vision models, it's obviously based on vision. It doesn't have to be based on vision. There's a section of multimodal foundation models that I'm going to discuss also. So this is there's also a paper, by the way, at NeurIPS that has discussed this, the multimodal foundation, which connects sound and video, which is something that autonomous driving could also take advantage of. But again, I think we want to kind of step away from the task-specific foundation models towards general embodied decision-making, and therefore having multimodal is almost a foregone conclusion here, because if you have, let's say, an autonomous robot, a humanoid robot, the humanoid robot might actually make decisions based on sound. It might make decisions based on touch, on haptic sensors, or even on things like smell. So there's definitely upside I think multimodal is a little bit underrated in a sense that people kind of just always squeeze it in. But I think in itself, it's a very interesting research subject, because you could, let's say, ask yourself, if you just concatenate sound and video, are you really representing the environment correctly? Or maybe you have to do more than just concatenation. So this is just but again, this is just a prelude. So hopefully today I can start with some more technical conversations about this particular paper that I'm going to start the series with. I'm going to continue with the general not in run conversation, in particular also talking about our performance, talking about the markets. This video, this AI series will be just focused on AI. There won't be any updates, there won't be any conversations about the market. The reason we're doing this is because, again, we believe that the bulk of value creation in the next 5 years will come from foundation models for decision making in general and embodied decision making in particular. Thank you.